we are going to take a look at how to draw the graph of the sine function. So I want to start out with thinking about the unit circle, which I sketched you one here before you joined me. And I just want to go around here and look at our quadrantal angles. So let's start here. We have 0 degrees, okay, or 0 radians. Up here, pi over 2. Around the side here, we're at pi. The bottom, 3 pi over 2. And then we're back here to 2 pi, okay? I also want you to think about in terms of coordinates. The sine, if you remember, is going to be y, the y coordinate. Okay, so when you look at the quadrantals, the zeros and the ones, you'll be able to pick out which value is which. Okay, so on a previous chart, I had you go through with the radians, okay, and convert those to decimals. Okay, so if I start here with 0 radians, okay, then next up as we go up and around, we would be at pi over 2. Which again, on a previous chart, you calculated that to be 1.57. Okay, come on around to pi, we're at about 3.14. 3 pi over 2 would give us 4.71. And lastly, we come on around the circle and we're at 2 pi, which is approximately 6.28. Okay, so that takes one cycle around the circle, okay, and that's called a period. Okay, so we're going to say for our sine graph, the period is going to be 2 pi. We can do one cycle of the sine between 0 and 2 pi. All right, so then what are the values of sine at the different locations? So at 0, okay, our sine value is 0. Again, look at the y coordinates. At 1.57, we're at 1. 3.14, you have 0. 4.71, you have -1. And at 6.28, we are back around to 0. Okay, so we're going to cycle between 0 and, between 1 and -1 for mins and maxes. All right, so I have a little grid down here. Let's do this is 1, down below here, -1. And let's plot our points. Okay, in fact, let me put the scale on here first. See if we can just do, didn't think about this before I started taping, so let's see here. Let's see if I can spread this out. 1, that isn't gonna work. Okay, back up the truck here. Well, this was gonna work, and now I just messed it all up. All right, sorry folks. Let me get back here with you so it looks a little better. Help if I have my x-axis on here. There we go. Sorry for that interruption. All right, so let's see here. We've got 1, 2, 3, 4, 5, 6, and 7. So I'm just spreading that out just a little bit so you can follow the grid. Okay, so here we go. So at 0, the sine starts at 0. Okay, at about 1.5, so 1.57, we're going to go up to 1. Okay, so 1.57, better known as pi over 2. At 3.14, we're back to 0. At 4.71, we're down here at -1. And at 6.28, we're back to 0. Okay, and then the sine curve. Nice and wavy. All right, so that one cycle of the sine curve, or one period, happens between x is 0 and x is 6.28. Okay? All right, continuing on, let's see if we can analyze our sine curve. Okay? So, domain for the sine. Okay? Domain, this graph would continue, cycle for as many as we want. So we can say it's from -infinity to +infinity. Okay, the range will go between -1 and +1, and I'm going to bracket that because it does in fact touch those two. Is the sine curve continuous? Yes, it is. Is the sine increasing or decreasing? I'm just going to say it's going to alternate in waves. Okay, for these two, okay, because we go back and forth alternating between. Okay, is it symmetric? We're going to say yes. With respect to this time, it would be the origin. Okay, and the sine is going to be known as an odd function. If you remember, we've talked about those. Extrema, we have absolute. Extrema with the max of 1. We also have an absolute min at -1. As far as VA and HA, we have none. So no VA, no HA. Okay, in fact, in behavior limits, we don't have an in behavior. We just say these two don't exist. Okay, and then lastly, I put on about the period of the sine graph. That's going to be 2 pi. Okay, so again, this is just the real basic unwrapping of the unit circle to get just your standard sine graph. Thank you.